Welcome, Hornets, and thank you for joining me today. Today we're going to be looking at perpendicular cross-sections using the worksheet that I have put in front of you. So we're going to be looking at semicircles, and we'll also have rectangles with half the width. Okay, so just be aware, we're going to start with number one. The base of a solid is the region enclosed by the semicircle and the x-axis. And we're going to have the cross sections be rectangles where the height is half that of the side of x in the xy plane. Then we're going to be taking a look at a solid is the region enclosed by y equals negative x squared over 4 plus 4 and y equals 0. The cross sections are going to be semicircles. Then we're going to take a look at number 3. The base of the solid is the region enclosed by the circle, and we will have cross sections that are perpendicular to the y-axis and our semicircle. And then we have the base is going to be an ellipse with the major axis along the x-axis. It will be 14 in length, and the minor axis will be 4 in length. The perpendicular cross sections are going to be semicircles perpendicular to the y-axis. Okay, let's go ahead and begin. So starting with number 1. Now, when you do this, I always recommend that you try to draw a picture. A picture is worth 1,000 words for us, and it will help us to figure out what it is we're doing. So, here's my picture. I'm going to put it on my axis. I can see I'm going from negative 7 to positive 7, and I can see that my y-intercept is also 7. So we can clearly see we have a semicircle. The semicircle has a radius of 7. And we want to have perpendicular to the x-axis are rectangles. And the side of this rectangle, let's call it the length. And the length is going to be the upper equation, which is the square root of 49 minus x squared minus the lower. And this is giving me my length. My height is coming up. This is sticking up out of the plane. And this height right here is half the length. So I'm going to make sure that I have my height. And my height is going to be 1/2 the square root of 49 minus x squared. Now at this point, I'm going to work with the area of this rectangle. Length times height, and we're going to have 1/2 of our length, so I'm going to replace that. I can do it in 2 steps if you want. Let's do it in 2 steps. The length times height, which is going to be the length times 1/2 of my length repeating itself, so that's going to be half of my length squared. So putting it together, I am working with my length, which is the square root of 49 minus x squared. It is being squared, multiplied by 1/2 dx, and I'm going from negative 7 to 7. Now when I do this, I prefer to use my even power rule. That means that I'm going to be cutting it down and only taking half of it. That means I'm going to double my volume, 2 times 1/2, 0 to 7, and I'm going to square my square root, leaving me with 49 minus x squared dx. I'm left with now 0 to 7, 49 minus x squared dx, which I now integrate to be 49 minus 1/3 x cubed. And I'm going from 0 to 7. And when I plug in the 7, where's my x? X, put your x in. There we go. All right. Now when I put my 7 in, I end up getting 686 thirds. And that's my answer. And this is the answer to number 1. Oop, there went my lights. Always a joy coming in on the weekend, everybody. Let's go ahead and go to number 2, please. So number 2 is now talking about a semicircle again. We're talking about along the x-axis, so y equals 0, And our curve is going to be the upper minus lower, just like we had before. And this upper point is x comma negative x squared over 4 plus 4. We're talking about semicircles going like that. So here is my diameter of this semicircle. And the diameter is going to be negative x squared over 4 plus 4 minus 0. Since I really want my radius to go into the formula of pi over 2 r squared dx, and this will be from negative, let's just check this, negative 4 to 4. Y-intercept is also 4. So I'm going from negative 4 to 4. My radius has to be half the diameter. So half the diameter equals the radius, and that has to be 1/2 of negative x squared over 4 plus 4. So I'm going to put that in. Keep in mind that that 1/2 is going to make this negative x squared over 8 plus 2. Okay. So putting it together, we're looking at pi over 2 integrated from negative 4 to 4 of negative x squared over 8 plus 2, the quantity squared dx. And this is what I'm now going to integrate. Now, when I FOIL it out, I am going to get a very ugly 1/64 x to the 4th minus 1/2 x squared plus 4, and this is dx. I'm going to use my even power rule to multiply it by 2 and take it from 0 to 4, and it now only has pi in front of it. And I begin my integration. So 1/64 times 1/5 x to the 5th minus 1 over 2 times 3 x to the 3rd plus 4x, and I'm going from 0 to 4 multiplied by pi. Now when I plug in my 4, notice the 0 just has it go away. That's why we like that even powered rule. It allows us to plug in that 0, which we know will always just drop away. So when I multiply and I put this all together, I get left with 128/15, which I then multiply by pi for my answer. This brings me to number 3. Now, number 3 is dealing with this circular shape. And they want us to use semicircles perpendicular to the y-axis. So we have a semicircle sticking up, and this will be my diameter. But watch out, because that diameter goes from this point, and this point is the positive square root of 49 minus y squared, to the negative square root minus y squared, y. So the diameter has to go from left minus right, and that gives me 2 square root, 49 minus y squared. Now please be aware, if you had decided to use the x-axis, it's still a circle, still symmetric, and if you do this, you get the same diameter. All right, so whether you decided to use the negative 7 to 7, and we're going along our axis from negative 7 to 7 on this one, I'm going negative 7 to 7 pi over 2 for 2 of these square root 49 minus y squareds, and I want my radius, so I'm going to divide it in half, and then I'm going to square it dy. Okay. So far so good. We're just cruising along. Now keep in mind that on this one, had you decided to do this shape, you would be looking at pi over 2 integration from negative 7 to 7, and you would have 2 square root 49 minus x squared over 2 squared dx. And you notice they're the same thing. In both cases, we're going to use our even power rule. It's going to give us pi, integration 0 to 7. The 2's are going to cancel. The radical is going to get moved away, leaving me with 49 minus y squared dy. This gives me pi multiplied by 49y minus 1/3 y cubed, 0 to 7. And just as we saw before, we're going to get 686 thirds, and I multiply by that pi, and that's going to give me 686 thirds pi. And there's my answer. The last one that I'm going to be doing with you is working with a semicircle, or semicircular shapes that are sitting inside of an ellipse. So let's just look at it one more time. The base of a solid is a region enclosed by an ellipse with a major axis of 14 along the x-axis and a minor axis of 4. The perpendicular cross-sections are perpendicular to the y-axis and are semicircles. Now, unlike the previous problem where we had circles where we were allowed to work from upper minus lower, here, because we're dealing with an ellipse, we have no choice but to work with our right minus left. Just trying to make sure I have something that looks like an ellipse. It's going along the x-axis. It's going to be from -7 to 7. Notice the length 14, and then up to 2 and down to -2. I'm being asked to work with semicircles perpendicular to my y-axis. There they are. We have pi over 2 integrated from -2 to 2, and we need our r squared. So let's just see what we've got. If I find this figure, this is x squared over 49 plus y squared over 4 equaling 1. That means that I'm going to have 4x squared plus 49y squared equals 196. And I need to get it into an x equals. So I have 196 minus 49y squared divided by 4 to the square root. And you have one that's going to be the positive and one that's going to be the negative. That's going to give you 2 of them. Notice that the square root of the 4 in the denominator is going to cancel with the 2 in the numerator. And keep in mind, all I currently have is my, let's just make sure. So all I have is my diameter here. So if I do my diameter, keep in mind that I'm going to do this, and that's my diameter. But I'm going to have to put another 2 underneath, because if this is my diameter, that's my radius. Yikes. I'm going to be using my even power rule so I can start from 0 and go to 2. And I want to factor out that 2 so that I have pi over 4 integrated 0 to 2. The square gets rid of the square root. And it's a dy. I'm now going to go ahead and I'm going to integrate. That's going to give me 196 y minus 49 thirds y cubed from 0 to 2, then multiplied by pi over 4. Now when I plug this in and multiply and divide, I end up getting 196 thirds multiplied by the pi, and I get 196 thirds pi. And that's my answer to number 4. And this is the examples that I have for you today. I hope that they have helped. If they have, please remember to click like. If, however, you have constructive criticism for me, please remember to let me know so that I can improve my videos. Thank you very much, Hornets. I appreciate you being here with me today, going through and giving these a try. Just be aware, the answer key was put online, and if you have questions further for me on Monday when we begin school, I will be happy to go over them with you. Thank you all. Be well. Take care. Cheers, Hornets. Be safe, and thank you. Bye-bye now.